Hello, and thank you very much for peer reviewing my work. This is Diego Souza speaking here. This is my final project for CSCA 5632, Introduction to Machine Learning and Supervised Learning with University of Colorado Boulder. The idea of this project is to apply and showcase all the techniques that we've all learned during the unsupervised learning course, during all the quizzes, all the lectures, and all the exercises that we all did. The idea to and with that find hidden patterns and latent features that can differentiate brand and brand, company and company. um, the hypothesis that I'm pursuing here is that a company can be very well compliant to environmental, social, and governance practices, but a specific brand might not be as well. Or maybe if it's the inverse, so the brand can be very well compliant with that, and the company can underperform. The data set that I'm using here is based on my supervised learning, and again, it's based on ESG, environmental, social, and governance. It has data along the company and the brand for diverse data as demographics and other KPI indicators. We have operational features, some metrics, and even some accusations, some awards, etc. Its shape is 3,605 brands, many industries, many parent companies, 77 features. Methodology is nothing new for us. There's data loading, pre-processing, feature engineering, selection, scaling, then PCA for dimensionality reduction and latent feature discovery or detection, hyperparameter tuning using grid search CV. Then I cluster the result of that with utilizing the optimal parameters from step number six. I'm using three models, k-means, hierarchical, and dbScan. K-means will be the baseline, hierarchical will be the one that I chose, the way to go. dbScan will be for detection for outliers or the noise detection. I have some cluster interpretation plots, and at the end I have a validation, and of course I'll derive my conclusion and next steps. During the presentation, please feel free to stop and go to the repository or to the Jupyter notebook you have access to. And I'll put here minimal snippets of code and some plots when it pertains. For example, here I'm combining some of the features of the raw dataset to get a greenwashing score, some other risk scores, and at the end, compute a global risk score, and which is the one that I'm plotting here in this figure number one. I continue doing the feature selection for clustering and doing some coding. As we all know, PCA needs a numerical features in order to perform, and I needed to convert many of the categorical variables or categorical features to numerical in order to apply PCA. So again, feel free to check the appendix and the repository for more information. As for scaling here, we see some arbitrary numbers here. Don't be afraid of that. Again, this is an academic work, not a commercial work. I have some industry knowledge on that, so this is my best guess. Of course, if that was a commercial product before throwing to the market, I'll have someone more expert than I vetting these numbers and adjusting if needed. I created something I call divergence and hypocrisy to analyze if there's any potential lying here. Turns out very few brands are not lying at all, according to the data set. Okay. And there's no real difference between the regular brands and the ones that I'm calling premium brands. So the distribution looks very, very similar. Next, I apply PCA, and the discovery here is that with 15 principal components, we can respond for more than for approximately 95% of the whole variance of the dataset, which is good for this experiment here as an academic one. And to avoid hours of CPU time, I'm only using the first three or sometimes four principal components for the plots, for the analysis. Again, you have my code. Feel free to put the number of PC A's do you want to have there and see if it has any valid difference or not. Here I have the top features per component. I'm only displaying here PC1, but in the code I have PC1, 2, and 3. And as for the top features, right, I mean the textual one in this plot is this guy here only. So to discover here some features will impact positively, like green, meaning likely the brand or the company is lying. Some other features will impact negatively, meaning uh, company is not advertising the good stuff they're doing on ESG fronts. Interesting finding to me here is a positive, innovative company or brand is likely not performing very bad on ESG. So meaning innovation means, at least in this data set here, means good ESG score or potential good ESG score. I have a heat map here of the latent features. I'm not spending much time on that for the brevity of the 15 minutes of this video. I have to kind of speed it up. Feel free to pause the presentation and look one by one if you need. Again, more visualization comparing PC1 and 2 based on environmental risk here and based on revenue here. Um, they are pretty much the same, sort of some outliers here and there. Um, and we'll see during the presentation, we have a very big one, which is an outlier and especially in revenue. Um, let's go. Next step is to do hyperparameter tuning. So I'm not displaying any performance or any metrics for the untuned models. I'm only displaying that for the tuned models. So this one is the k-means, and I'm tuning using this code. I ended up creating a class to do the hyperparameter tuning, and here's just a snippet of those plots over here. The metrics that I'm using is silhouette. This is the main one. Kalinsky-Harabas, Davis-Boudan, and inertia for k-means. For the next one, hierarchical, I'm using only silhouette, Kalinsky-Harabas, and Davis-Boudan. And here's interesting to see how the linkage works, right? Good stuff that we learned during the course. Very interesting. The next one is the DB scan. Again, this guy is only for, or mainly for, noise detection. We see the silhouette score heat map. Likely, the data set is very homogeneous, and actually, this is one of the discoveries that my conclusion has, and this is part of the proof. The best models, this is one of the deliverables from the rubric. The best model is the hierarchical with a silhouette of 94%. Very well, very good silhouette. A good Davis-Boudan as well. Number of clusters, unfortunately, not good at all. Noise is good, but this guy doesn't detect noise at all. Same for k-means. Best parameters here. DB scan is for outliers and noise, as I explained. Please feel free to stop the presentation and read through if needed. I'm plotting here some of the plots for the hierarchical, which is the best model I'm looking for. Um, in any case, I have the dendrogram. I'm not a big fan of the dendrogram chart, but I'm plotting in any case. I'm just not a big fan of that. The distribution using scatter plots. This guy looks, those groups looks like a little bacteria growing here. Very interesting. And here, again, what I was talking about, we have a very big cluster here with 3,604 items and only one guy here in cluster number one. Well, we'll soon find out who this guy is. Best DB scan is plotted here. It's very similar to the scatter plot distribution that we had in the other slide. The difference here is you see these little gray things here. Those are noise. Noise here is in my case, are the brands that we couldn't put in any of the clusters. Here the k-means baseline again. Here I have more cluster interpretation, and please feel free to check graph by graph. And remember that we have a sole brand in the cluster number one. It's an e-commerce one. Guess who? It's Amazon. See the revenue here is a massive thing. Well, in any case, moving forward, my honest assessment on the clusters, hierarchical is the one to go. Two clusters is not enough, especially one having almost everything in a single one plus one outlier. Um, this diverges very much from my initial expectations, and that makes me think: is this a failure or not? Again, this is a scientific experiment, not a commercial one, at this point at least. So the find itself is one insight. So that answers the question. This is not a failure at all. I applied the rigorous methodology, and from 70 something features that I had, only 25 features were useful. I applied many hyperparameter combinations. I applied PCA, and one of the byproducts here is a interpretable heat map of latent dimensions. I performed outlier detection, and it was all done by the books, all done through the ladder of what we learned during the course. So I'm happy. It was not the result that I was looking for, but I'm happy that I can continue this work. So future work here, I'll use this clean data set because now also as a byproduct of this experiment is a CSV file with the buckets and all the good information that I could derive from the unsupervised learning. So I have the deep learning project to deliver as well in this term, and I will apply this data set into um, the deep learning project. So my acknowledgement of limitation, 25 features here, is probably not enough for differentiate brand to brand. The data is highly homogeneous and it's very imbalanced now. So, as my final word, the journey will continue during the deep learning project. My idea is to apply generative adversarial networks of some sort, probably from pre-trained, in order to solve the imbalance of this data set. So that's the idea. Have the references. Everything that I use, including the dataset, originates from the GHG Shopper application. I have an appendix with many, many details here. Feel free to dive into it if you have the time to. Thank you very much.